Hello there, Assalamualaikum. It's Cikgu Zana here. Hope all of you are doing well. In today's video, I will be sharing a lesson on a semester 3 topic, which is game theory. And our main focus is on mixed strategy. So please do watch until the end of this video. Before we start, if you are new here, go ahead and press the subscribe button and the small bell so as not to miss my new videos. Let's recall the play safe strategy learned in the previous video. The play safe strategy is where each player will choose one single strategy to minimize the risk. The role player will choose the maximum strategy that will maximize his minimum gain. The column player will choose the minimax strategy that will minimize his maximum losses. When the value of the minimax is the same as the value of the maximum, then there exists a saddle point. Thus, the game is said to have a stable solution. So what is a mixed strategy? Let's consider the two-person zero-sum game. The maximum value is -2. The minimax value is 3. So the play safe strategy for player A is to play strategy X1, and the play safe strategy for player B is to play either strategy Y1 or strategy Y2. However, the maximum and the minimax values are not the same. This means that there is no saddle point and the game has no stable solution. In the case where no stable solution exists, a mixed strategy is used. So a mixed strategy is used in which each of the strategies is carried out with a given probability to find the optimal solution. The optimal mixed strategy for the role player is to maximize his expected payoff, and the column player to minimize his expected payoff. So let's determine the optimal mixed strategy for the two players and the value of the game. First step is to assign the probabilities. For player A, since there are two choices of strategies, assign a probability P to player A's choice of strategy X1 and 1 minus P to player A's choice of strategy X2. Similarly, for player B, assign probability Q to strategy Y1 and probability 1 minus Q to strategy Y2. Next is to find the expected payoff for player A based on player B's strategies. If B plays Y1, the expected payoff for player A is -2P plus 3 times 1 minus P, which gives us 3 minus 5P. If B plays Y2, then the expected payoff for player A is 3P plus -4 times 1 minus P, which gives us 7P minus 4. Equalizing, since player A's expected gain is the same regardless of player B's strategy, we have P equals 7/12. Thus, the optimal strategy for player A is to play X1 with a probability of 7/12 and X2 with a probability of 5/12. To find the expected gain for player B, the positive values in the payoff becomes negative and the negative values become positive. Thus, the expected payoff for player B based on player A's strategy is, if A plays x1, the expected payoff for player B is 2q minus 3 times 1 minus q, which gives us 5q minus 3. If player A plays x2, the expected gain for player B is negative 3q plus 4 times 1 minus q, which gives us 4 minus 7q. Equalizing, we have q equals 7/12. Therefore, the optimal strategy for player B is 7/12 and 5/12. So, value of the game is equivalent to the expected gain of the row player, which is 7p minus 4. Substitute p, 7/12, we have 1/12. Notice that by using mixed strategy, both players have improved their positions. That is, the expected gain of 1/12 for player A is greater than the maximum value of negative 2. The expected loss of 1/12 for player B is smaller than the minimax value of 3. The optimal mixed strategy can also be found using the formula method, which is only applicable for a 2x2 payoff matrix. If the payoff matrix is given as A, B, C, D, and assigning the probabilities to player A and B choices of strategies, then the optimal mixed strategy for player A is P and 1 minus P, and player B is Q 1 minus Q, where the values of P and Q are obtained using the following formulas. The value of the game can be obtained using the formulas. And notice that the denominator for P, Q, and V are all the same. Equate the payoff matrix with the matrix A, B, C, D, where A is negative 2, B is 3, C is negative 4, and D is 3. Thus, the values of the probability P and Q are obtained by substituting the values of A, B, C, and D into the following formulas. So P is 7/12 and Q is also 7/12. Thus, the optimal strategy for player A is 7/12, 5/12, and player B is 7/12, 5/12. Value of the game can be obtained by using the following formula. Substitute P 7/12 and A negative 2 plus 1 minus P, which is 5/12, times D, which is 3, we have 1/12. Or we can use the following formula. Find the values of AC minus BD divided by A minus B, which is negative 5, plus C minus D, which is negative 7, and we have 1/12. In this example, we are required to find the optimal strategy for each player and find the value of the game and state which player does the game favor. Since the question did not state optimal mixed strategy, hence we must determine whether the game is stable or unstable. The maximin and the minimax values must be obtained to determine whether the game is unstable. Thus, the row minimum of S1 is -2, S2 is -3, hence the maximum value is -2. The column maximum of A1 is 4, A2 is 6, hence the minimax value is 4. Clearly, the maximum value is not the same as the minimax value. Then, there is no saddle point, thus the game is unstable. Hence, both players must apply the mixed strategy. Using the equalizing method, or sometimes known as the equilibrium method, we can find Shah's and Abu's mixed strategy. So, for Shah's optimal strategy, find Shah's expected payoff by referring to Abu's strategy. If Abu plays A1, Shah's expected payoff is 4p plus -3 times 1 minus p, which is 7p minus 3. And if Abu plays A2, Shah's expected payoff is -2p plus 6 times 1 minus p, which gives us 6 minus 8p. Equalizing, solving, p is 3/5. So Shah's optimal strategy is 3/5 and 2/5. So to find Abu's optimal strategy, we have to find Abu's expected payoff by referring to Shah's strategy. So if Shah plays S1, Abu's expected payoff, remember, since this is gain for Abu, the negative sign becomes positive, the positive sign becomes negative. So here we have -4q plus 2 times 1 minus q, which is -6q plus 2. If Shah play S2, so the expected gain of Abu is 3q plus a -6 times 1 minus q, which gives us 9q minus 6. Equalizing, solving, q is 8/15, thus Abu's optimal strategy is 8/15 and 7/15. The value of the game is the expected gain for Shah, which is 7p minus 3. Substitute p as 3/5 and we have 6/5. Since the value of v is positive, game favors Shah. The formula method can also be used to find the optimal mixed strategy for the players. Equate the payoff matrix with the matrix A, B, C, D. Thus, A is 4, B is -2, C is 6, and D is -3. So the value of P is obtained by substituting the values into the formula. So P is 3/5. So Shah's optimal strategy is 3/5 and 2/5. Similarly, Q is obtained using the following formula. Substitute the values and we have Q equals 8/15. So Abu's optimal strategy is 8/15 and 7/15. Value of the game is obtained using the formula, and substituting the values we have V equals 6/5. Since V is positive, game favors Shah. In this example, we are given a 2x3 payoff matrix. We are required to use the graphical method to determine the optimal mixed strategies for the two players. Since the question states mixed strategies, thus we do not have to show that the game is unstable. First, find the expected payoff for player R. If player S chooses S1, then the expected payoff for R is 4p plus 1 times 1 minus p, which gives us 3p plus 1. If player S chooses S2, then the expected payoff for R is 3p plus 2 times 1 minus p, which gives us p plus 2. If player S chooses S3, then the expected payoff for R is negative p plus 2 times 1 minus p, which gives us 2 minus 3p. Next, the expected payoff for player R is plotted as functions of p for the values of p from 0 to 1 inclusive. Plot the x-axis that represents the value of p and the y-axis that represents the expected payoff for player R. Then draw the first line that represents the first expected payoff, which is 3p plus 1, the second line that represents the second expected payoff, p plus 2, and the third line, the third expected payoff, 2 minus 3p. Now player R wishes to maximize his minimum expected payoff. Thus, the value of p is the value that peaks at the bottom line, which is the point of intersection of line y1 and y3. So at point of intersection, 3p plus 1 is the same as 2 minus 3p, evaluating p is 1 over 6. Thus, the optimal strategy for player R is 1 over 6 and 5 over 6. Note that the graph is not necessarily drawn on a piece of graph paper. To find the optimal mix strategy for player S, we are going to find the expected loss instead of expected gain, so that the positive and negative values in the payoff remain the same. If player R plays R1, the expected loss of player S is 4q1 plus 3q2 minus q3. If player R plays R2, the expected loss of player S is q1 plus 2q2 plus 2q3. Next, find the expected gain for player R by substituting p equals 1 over 6 into 3p plus 1, and we have 3 over 2. In other words, the expected loss for player S is 3 over 2. We can now have three simultaneous equations to find the values of q1, q2, and q3, which are the sum of the probabilities is 1. If player R plays R1, the expected loss of S is equal to 3 over 2. If player R plays R2, the expected loss of player S is equal to 3 over 2. The values of Q1, Q2, and Q3 are obtained by solving the three simultaneous equations. Subtract equation 1 from equation 3, we have the values are substituted into equation 1. We have Q1 equals half. Equation 1 is added to equation 2. We have substitute Q1 equals half. Thus, Q2 is 0 and Q3 is half. Therefore, the optimal strategy for player S is to play S1 with a probability of half and to play S3 with a probability of half. The value Q2 equals 0 will be discussed and explained in the next video lesson in dominant strategy. Next example, two companies L and M competing against each other, and the payoff matrix is a 3 by 2 matrix. Again, we are asked to find the optimal mix strategy using the graphical method and find the expected gain for company M. The solution for part A. To determine the play safe strategy for company L and give a reason why this strategy is the best choice. So first we need to find the minimum values for each row. Row 1, the minimum value is -2, row 2 is 1, row 3 is -1. Hence the maximum value is 1. This indicates that the play safe strategy for company L is strategy L2, since it will minimize the loss. For part B, it is not possible to draw a two-dimensional graph for company L, since it has 3 choices. So we invert the payoff matrix so that it becomes a 2 by 3 payoff matrix, which in company M's favor. Thus, if player L choose L1, the expected payoff for player M is 2 minus 6p. If player L plays L2, the expected payoff for player M is 2p minus 3. And if player L plays L3, the expected payoff for player M is 6p minus 5. Then we plot the expected payoff for player M as functions of p for the values of p in the range from 0 to 1 inclusive. Plot the x-axis that represents the values of p, the y-axis that represents the company M expected payoff. Then the first line is drawn to represent the first expected payoff, 2 minus 6p, and the second line to represent the second expected payoff, 2p minus 3, and the third line to represent the third expected payoff, 6p minus 5. Since company M wishes to maximize the expected payoff, thus the value of p is the value that peaks at the bottom line, which is the point of intersection between line y1 and y2. So at the point of intersection, 2p minus 3 is the same as 2 minus 6p, and we have p equals 5 over 8. Thus, the optimal strategy for company M is to play strategy M1 with a probability of 5 over 8 and to play strategy M2 with a probability of 3 over 8. And the expected payoff for company M is obtained by substituting p equals 5 over 8 into the equation 2 minus 6p, and we have -7 over 4. Summary for today's lesson. If the minimax and maximin values are not the same, the players are advised to apply the mix strategy, where the probabilities are assigned to each strategy. To find the optimal mix strategy, if we have a 2 by 2 payoff matrix, we can use the equalizing method and the formula method. If we have 2 by 3 payoff matrix, we use the graphical method. And if we have a 3 by 2 payoff matrix, invert to 2 by 3 payoff matrix and use the graphical method. That's about all. So I end this lesson with a saying, practice makes perfect. Please do visit my channel for more video lessons. Till then, bye for now and see you again in my next video.